And we're looking at the area of a circle and then the area of part of the circle, and then as well as some arc length. So on page 10 of your study guide, we'll start with arc length and work down this column, and then we'll go back and hit sector area. Arc length is defined as essentially just the distance along part of a circle, but basically any arc. If you know the radius, we can find the length of that arc. So fill in that definition, and then here's a picture, kind of finding the length of this arc right here. Uh, just a portion of the circle, so not the entire circumference, but part of it. So now let's take a look at how we're going to do that. We're going to use this formula. The general formula is to compare the part to the whole. And there's two ways that we can define a circle. We can define it as the circumference all the way around, and that's determined by the radius. But we can also define it as the measure of the angle all the way around being 360. So if we only want part of it, we can find part of the circumference if we know part of the whole angle, which is that 360. So we can kind of take this general rule, part over whole is equal to part over whole, and we can make it more specific. For arc length, we're going to compare part of that length to the whole, so that's the first part, arc length over circumference, and we compare that, it should be proportional to that part of 360, so the central angle over 360 degrees. Whenever we're given a radius, we will use the circumference formula, 2 pi r. You also can jot in right now that if we're given a diameter, then the circumference is equal to just pi times diameter. So we can plug those things in. We know that we're always going to have 2 pi r on the bottom. That's your circumference of the whole. And then our arc length is our unknown in these situations. And then we just match up with the part on the other side, the part being the angle. This is a Greek letter, theta. We use that for angle measures in geometry a lot. And we'll go ahead and take a look at the first example. So we're going to try to find the indicated measure, and just carefully look at this. We're going to try to find the arc length of AB. So you can see kind of that arc mark up there, not unlike segments, but a little curved mark, and that means we're just trying to find the distance, the shortest distance between A and B. We're not looking for the other way around. You could define this as AB, but general protocol says always the shortest one. If we want a longer one, we'd have to add in a different letter on the other side. So the first thing that I'll do is find the entire circumference. So what's the whole? We've got a radius, so it's 2 pi, and then our radius is 2. So I'll just leave that as 4 pi for right now. Now this measure, we'll call it x. That's part over the entire thing, which is 4 pi. Okay, so we don't know the part. Then when we write our proportion, or our ratio here now is the same, then what's our part? Well, we've got the angle measure, theta. Theta is equal to 88 degrees. So that's the measure of this angle in here. We know that 88 degrees is the part over the whole thing, the whole way, all the way around the circle, 360 degrees. Now we have a proportion with only one variable. We can solve this by cross-multiplying. So we would multiply one direction is 360 times x, the other direction 88 times 4 pi. So it'll be 360x equals 88 times 4 is 352. And then we can still leave the pi for now. And our final answer, we'll multiply it all out. Divide both sides by 360. And x equals, I'm just going to plug that whole thing in my calculator, 352 pi divided by 360. So that arc measure is 0.03. 0.37. I want you to pause the video right now and try to do that same thing with the bottom one. Alright, so you've tried that one, and we'll just set up the same way here. The whole circumference is 2 pi times 4, which is equal to 8 pi. So we're trying to find this length, which is x over the whole thing, 8 pi, equal to the other direction, or the angle measures now, 97 degrees over the whole thing, which is 360 degrees. Cross multiply again. And you should have 6.77 feet. Alright, so a pretty general formula because it works for both sides. When we go back up to the top, we'll use that same thing. Sector area is just an area defined as 2 radiuses or radii, and then now we're connecting the two. So we're trying to find that green shaded area. Again, we're going to look at the part of the area we're looking for divided by the entire area, and we'll compare that to the part of the angle measure divided by the whole angle all the way around, 360 degrees. More specifically, we can fill in some parts of the formula. Area is always uses radius, so it's always going to be pi r squared. So it's x, our unknown, over pi r squared is equal to theta over 360. So let's try an area problem. Again, I'm going to find the area of the whole. Pi, radius in this situation is 5, so it'll be pi 5 squared, which is 25 pi. Now we're trying to find the part, so I will label this one as my x. X over 25 pi, part over whole, okay, that ratio should be equal to our angle measure in this situation, 63 over 360 degrees. Again, we'll cross multiply. One direction this way, other direction. You're going to end up with 360x is equal to, I'll just multiply the numbers right now. We'll multiply out pi. 63 times 25 is 1,575. And then a pi. Divide both sides by 360 in order to solve for x. And x equals 13.74. We don't have any units, so it's just square units. All right, go ahead and try this bottom question. Pause the video here, and then we'll see how you did. All right, we'll start with the same thing, whole. The whole area will be pi 9 squared, which is 81 pi. So we'll set up our area formula, area part of the proportion x over 81 pi is equal to, this time we're using 106 degrees of the whole thing, which is 360. Cross multiply and solve. And x is 74.9. I'm going to round it up to 3. This time we do know it's square feet.